Hi, welcome to your 7-3 flip video. 7-3 is about adding algebraic expressions. So we already know what algebraic expressions are. Algebraic means it has variables in it. Expressions are like equations except for they don't have equal signs. So an algebraic expression would be like 7x plus 3 or 4x plus 2, and now we're going to add them together. Okay, so in order to know how to do that, we have to first define the parts of an algebraic expression. So let's say I give you 9x plus 4y plus 2/3 z plus 11. Now there are certain things in there. We have terms, coefficients, constants, and this last one isn't really a thing, but terms of a difference, and it's important to talk about just very quickly. So I put an asterisk by terms of a difference because it's not a part of adding algebraic expressions. It's more of just an idea on how to rearrange them. So I'm going to color code this, so everything will be color coded accordingly. So terms, 9x is a term, 4y is a term, 2/3 z is a term, 11 is a term. So what's the definition of a term? A term is parts of an algebraic expression. They're the components. They're the pieces that make it up. Whoops, wrong order. But notice the colors. A term could be a variable or just a number. All right, so 9x is a term. 11 is a term. Those are all different terms. They're different parts of the algebraic expression. And you can't combine 9x and 11. We talked about that. So the number of terms is when you simplify your expression, the number of pieces that you have left over in that expression. Okay? So you can see the pink boxes already. I've pink boxed all the numbers in front of the variables, and those are your coefficients. So the official definition of a coefficient is number factor of a term. So the factor is something you multiply by. A term is a part of an algebraic expression. So it's the part of the algebraic expression that you multiply your variable by. That's kind of a not great definition. I think about it as the number in front of the variable. 9x, the number in front of x is 9. 4y, the number in front of y is 4. 2/3 z, the number in front of z is 2/3. So those are your coefficients. And then just remember, coefficients always come first, right? We would never write x3. We change that into 3x. It just sounds better, and we have just kind of agreed not to use coefficients second. Coefficients always come in front. All right, constants, that's my 11, and a constant is a term without a variable. You are constantly adding it. No matter what x, y, and z is, if x is 1,000,000, y is -1,000,000, and z is 25, you're always going to add 11. You are constantly adding 11 to it regardless of the amount of the variables. So it's constantly a part of the equation. It doesn't change. It is constant. No matter what all those variables equal, you're always going to add 11 to the end. Okay, in this case, your constant might be 100 or any other number. All right, so number of terms, number of parts, coefficients, numbers in front of variables, constant, terms without a variable. All right, terms of a difference. Let's look at an example, 2b minus 3. All right, I am subtracting 3. I am subtracting positive 3 minus positive 3, and we don't write that positive sign, but it's there. 2b minus positive 3. Subtracting a positive is the same thing as adding the negative. So I can change 2b minus positive 3 to be 2b plus -3. Those are the same thing. I'm just using adding or subtracting a positive, same thing as adding a negative. So terms of a difference is the answer to a subtraction problem. So for this first one, it's a subtraction problem, right? I have a minus sign in there. We're talking about adding algebraic expressions, so we can turn a difference into a sum, right? Sum is the answer to an addition problem. So we can turn the terms of a difference into the terms of a sum by using subtracting a positive is equal to adding the negative. All right, so it's just rewriting it to meet our requirements. All right. All right, so if you have 0.3a plus 6b plus 1/2 c minus d minus 50, what are the number of terms? What are the coefficients? What are the constants? So I'm going to color code again. Number of terms Well, you have 1, 2, 3, 4, 5 terms. And let's just be clear, I'm not pointing to the point 3. I'm pointing to point 3a, 6b, 1/2 c, d, 50. Those are each a term. So I have 5 terms because I have 5 arrows. I have 5 parts to this algebraic expression. What are your coefficients? Well, I'm going to circle those. 0.3, because 0.3 is the coefficient to A, 6 is the coefficient to B, and 1/2 is the coefficient to C. Now you'll notice I left off the coefficient to D. What number is in front of D? Well, there's a 1, right? It's 1D. But there's a minus sign. So let's use subtracting the positive as the same thing as adding the negative. So what's your coefficient? You can change this into adding negative 1D. So coefficients, okay, there we go, adding negative 1D. So your coefficients, you have 4 coefficients, and of those 4, your coefficients are 0.3, 6, 1/2, and negative 1, because those are the numbers in front of those variables. All right, constants, this is an easy one. You have that minus 50, so I'm going to change that to add negative 50. So what's your constant? Negative 50, and that's it. All right, now we have a little bit more complex of an example here. The quantity 5x plus 2 plus the quantity 3x plus 4. So you guys don't have to worry about the names of the properties, but the associative property tells me I can regroup any addition problem or multiplication problem. So I can basically get rid of the parentheses because this is an addition problem. If this was a subtraction problem or a division problem, I would not be able to do that. But for addition, order doesn't matter, so I can get rid of the parentheses. Now, let's combine like terms. So 5x and 3x, and I like to circle and use squares in different shapes to help me remember the terms that I need to combine. That's really helpful when you start getting into longer and longer terms, and we'll get to there in a second. So I'm going to circle all my x's in red, and let's box in all the numbers without variables in green. And now we can combine. 5x plus 3x is 8x, 4 plus 2 is 6. So 8x plus 6 is when you simplify this. So you're left with 2 terms, 1 coefficient, which is just 8. I'll put that in the parentheses. And you have 1 constant, which is 6. And that's it. All right. Another example. 5 times the quantity r plus 1 plus the quantity negative 8r plus 2. So we have some stuff we need to do beforehand. We can't just get rid of those parentheses because then that'll just give me 5r plus 5, which isn't what we're looking for. We have to distribute that 5 because it's 5 times the quantity r plus 1. So if you distribute that 5, well, 5 times r is 5r, 5 times 1 is 5. So 5 times the quantity r plus 1 simplifies to 5r plus 5, and then everything else just stays the same. But now we're just doing an addition problem, so I can get rid of those parentheses. So 5r plus 5 plus negative 8r plus 2. Let's circle all of the r's, and we'll box in all of the constants. So 5r plus negative 8r, 5 plus negative 8 is equal to negative 3. So 5r plus negative 8r is negative 3r, and then 5 plus 2 is plus 7. And they're both positive, so that's easy. So what do we have left over? Well, how many terms do we have? We have 2 terms. We have 1 coefficient, which is negative 3, because negative 3 is in front of r. And then we have 1 constant, which is 7. All right? So you have to distribute, you have to simplify your algebraic expression before you start saying, okay, I have this many terms, this coefficient, this constant. You have to simplify and combine like terms before you do that. All right? Here's a much more complicated example. 5 times the quantity x plus y minus 5 plus 3x minus 2y minus 4z. All right? So what are we going to do first? We're going to distribute. So 5 times x is 5x. 5 times y is 5y. And you'll notice that I just changed the minus 5 to plus negative 5, and I put a box around it. So this helps me remember I'm doing 5 times negative 5 because I changed the minus 5 to plus negative 5. Because I think that's a little bit easier to see if you're, now it's just 5 times negative 5 and a plus sign in between them. So plus, or yeah, let's change that to plus negative 25. Okay, now you could switch, adding the negative, same thing as subtracting the positive, so minus 25. But let's keep it like that. And now everything else just stays the same. 3x minus 2y minus 4z. So let's color code it. Circle the x's in yellow, square in our y's in orange. Notice I included the minus 2y in my box and not just 2, because that minus sign is important. Purple for the z's, pink for the constant. Now let's combine 5x plus 3x, 8x. Now my y's, I have 5y minus 2y, right? And you could change this to 5y minus 2y. That's the same thing as 5y plus negative 2y. Adding the negative is, subtracting the positive, same thing as adding the negative. 5 plus negative 2y is 3y. So however it makes your brain work, think about it like that. Z is all by itself, so I'm just going to leave minus 4z, and I rewrote minus 4z as plus negative 4z because we're doing addition. So I'm trying to get only plus signs in here, addition signs. So that's the same thing though, right? Adding negative 4z is the same thing as minus 4z. It's the same thing, all right? And then last part, plus negative 25. Again, that's the same thing as subtracting positive 25. So I'll just complete this. Change those, so 3y and then 8x. Okay, so you have either 8x plus 3y plus negative 4z plus negative 25, or 8x plus 3y minus 4z minus 25. Those are the same thing. All right, and then from here you can say, okay, I have so many terms, so many constants, so many coefficients. So how many terms? 1, 2, 3, 4 terms. What are your coefficients? Well, you have, switch colors, I'll use light gray for this. Your coefficients, 8, 3, negative 4, and that's it. And then, so 4 terms, 3 coefficients. Those coefficients are 8, 3, negative 4. And then I'll use black. What's your constant? Negative 25. All right? That sums up 7.3. Adding algebraic expressions. Tomorrow we'll talk about subtracting algebraic expressions. That's just one more step in the process. So if you are able to combine like terms and identify number of terms, coefficients, and variables, you're all good to go. All right? Let me know if you have any questions.